Okay, we're going to make a start now. So welcome everyone to our GCSE Maths session. In today's lesson, we're looking at cones and spheres. Okay, so it's basically a bit of a continuation of your volume of a prism, surface area. We've looked at normal prisms, we've looked at cylinders. Now we're going to look at cones and spheres. And this is the last sort of 3D shape that you will be required to know. The rest of the lessons, next lesson is on the area of a sector. Okay, so we're moving away from volumes of prisms, and then we're moving into sort of circles and that sort of stuff. So we're going to start off with this question first. So we've got this question. It says a solid is formed by placing a half cylinder on a rectangular prism. The solid has a width of 2 meters, a total height of 3 meters, and a length of 8 meters. We need to work out the volume of the solid. Okay, so as you can see, this is a compound shape. We have two sorts of 3D shapes present within this compound. We have a semi-cylinder, we have a half of a cylinder at the top, and then we have a cuboid at the bottom. So what we're going to have to do is we're going to have to work out the volume of the cuboid first, and then we're going to have to work out the volume of the semi-cylinder, which is at the top. And then we're going to have to add together the two volumes. And that's what we're going to do. So working out the volume of the cuboid, first of all, um, we know that this solid has a height of 2 meters, a length of 8 meters, and we know that it has a height of 3 meters. We need to work out the length of this solid. Now we know that the radius of this circle, this is a circle, right? Over here, this is a semicircle. And we know to work out the area of a circle, we need to know the radius of the circle. We know that this distance is 2 meters. So we know that the radius is going to be half of that distance. So it's going to be 1 meter. Okay, so the radius is going to be 1 meter long. And it's going to be that size in all directions. So it's going to be 1 meter long, and the height is also going to be 1 meter long because the height is also the radius. Okay, now if that is 1 meter long, then that means this distance over here is going to be 2 meters long. Okay, so in terms of working out the area of this cuboid, we know that the length is 2. It's not really a cuboid because, well, it is a cuboid, but the length and the width are the same, 2 meters and 2 meters. Okay, so if we want to work out the volume of this cuboid, we're just going to do length times width times depth. So we're going to do 2 times 2 times 8, and 2 times 2 is 4, and then 4 times 8 is 32. So the volume of the cuboid is 32 meters cubed. That's your volume of the cuboid. Now, once you've worked out the volume of the cuboid, we now need to work out the volume of the semi-cylinder. So we've got half a cylinder. So let's work out the volume of the full cylinder first. So volume of full cylinder. And the way that you're going to do that is we know that it's going to be the area of the cross section multiplied by the depth. So area of cross section multiplied by the depth. Now the cross section is a circle, so we're going to work out the area of the circle first. And the area of the circle is just going to be pi r squared. We know that r is 1 meter, so it's going to be pi 1 squared. So it's going to be just pi for the area of the full circle. And then we know that it's a semicircle, so we don't want the area of the full circle, we want the area of just the semicircle. So we're going to divide this by 2, so it's just going to be pi over 2. This is the area of the semicircle. Okay, now this is the cross section. The semicircle is just the 2D shape that is at the front. That's the cross section. And all you're going to do is you're going to multiply this by the depth. And the depth is how much through the shape, the semicircle has been stretched. So all we're going to do is we're going to multiply the area of the semicircle, which is pi over 2, by the depth, which is just 8 meters. So we're going to do pi over 2 times 8, and that's going to give us 4 pi. Okay, so that's your volume of your semi-cylinder. Okay, so we worked out the area of the semicircle. Yes, this is the starter. Um, we've worked out the area of the semicircle. That was pi over 2, as you can see over here. And then what we did was we multiplied it by the depth, which was 8, and we got 4 pi. All we're going to do now is we're going to add together 4 pi and 32 centimeters cubed. So 4 pi add 32 centimeters cubed. And what does it say? It says to three significant figures. So we've got 4 pi plus 32 centimeters cubed, and that's going to get us 44.6 meters cubed. Okay, so it's going to be 44.6 meters cubed, and that's what your answer is. Okay, so this was a question that we didn't get onto in our last lesson. So yeah, we do have another one coming up. It's slightly different, not the same, but we got another one coming up as well for you guys to have a go at. Just going over this for anyone who wants me to. All we did was we saw that this was a compound shape, meaning that there were two 3D shapes present within the same shape. And because there were two 3D shapes, we need to work out the volume of the cuboid at the bottom, and then we have to work out the volume of the half cylinder at the top, and then we need to add them together. So when we worked out the volume of the cuboid, all we did was length times width times depth. We knew that we've got a semicircle over here, and we know that the whole distance was 2 meters. So half the distance is going to tell us the radius, which is going to be 1 meter, and it's going to be 1 meter up as well. That means that this distance over here is 2 meters because the total distance is 3 meters. Okay, so we did length times width times depth, 2 times 2 times 8, and that gave us 32 meters cubed, and that was the volume of the cuboid. Once we worked out the volume of the cuboid, we then worked out the volume of this cylinder. We follow our normal formula, area of the cross section multiplied by the depth. The cross section, as you can see, is a semicircle. So we work out the area of the semicircle first by working out the area of the full circle, which is just pi, and then because a semicircle is half of the full circle, we just divide it by 2. Okay, so we just divided by 2 to get pi over 2, and that's the area of the semicircle. And then all you do is you multiply it by the depth of the shape, which is 8 meters, pi over 2 times 8. And then once you've done pi over 2 times 8, you get the area, you get the volume of the half cylinder, and then you just add the volume of the half cylinder to the volume of the cuboid that you originally got. And if you type that into your calculator, you get an answer of 44.6 meters cubed. Okay, so now what we're going to do is we're going to move on to the next question. I've got this question, which we never got into in our last lesson as well. And I want you guys to have a go at this first. And then I'll go through it with you as well. Once you've got an answer, type your answer into the Q&A, and then I'll go through it in approximately 2 or 3 minutes. And then what we'll do is we'll move on to cones and spheres of today's lesson. Yeah, I can soon. Okay, so the reason why the previous question was a rectangle is because it was a shape like if I just it was a shape like this. This was 2, this was 2. However, it was stretched out like this, and this was 8. If it for it to be a cube, um in order for it to be a cube, it has to be all the length, width, and depth have to be the same numbers. Okay, if these two are the same numbers, then it doesn't determine whether it's a cuboid. It has to be 2, 2, 2 for it to be the same cube. Okay, it won't be a cube if the numbers are different. So over here we had 2, 2, 8 because the numbers were different. That's why it's a cuboid and not a cube. Today we're looking at cones and spheres. Okay, just one more minute and then I'm going to go through the answers. Okay, I'm going to go through the answers now. If you're still working, don't worry. You still have time. You can still type in your answers into the Q&A. I'm just going to stop the explanation now. So it says a solid cylinder has a radius of r meters and a height of 12 meters. And it says the volume of the cylinder is 507 pi meters cubed, and we need to work out what r is. So remember, we're dealing with volume in this case. When we're dealing with volume, we know that it's going to be the area of the cross section, and we're going to multiply it by the depth. Okay, and in this case, the cross section is just the 2D shape, it's just a circle. The 2D shape, the main 2D shape that you can see is a circle. So the cross section is a circle. And because the cross section is a circle, you know, to work out the area of a circle, it's just going to be pi r squared. And in this case, we don't know what the radius is. We need to work out what the radius is. So we're just going to leave it as pi r squared because we don't know what the radius is. And we know that if we multiply that by the depth, which we are given, it's 12. When we multiply by the depth, that's going to give us an answer of 507 pi meters cubed. So we're going to have 507 pi meters cubed. Now, if we think about this now, let's just simplify this. If we multiply these two things together over here, we're going to get 12 pi r squared equals 507 pi. Okay, and all we're going to do here, you can see that there's a pi on both sides. Because there's a pi on both sides, what you can do is you can just cancel the pi's out because there's a pi on both sides. Or you can think of it as dividing by pi. If you divide by pi on both sides, the pi is going to disappear. Because we have a pi on both sides, we can just cancel them out. So we're just going to be left with 12 r squared, and that's equal to 507. Okay, and then all you're going to do is you're going to divide by 12 on both sides to get r squared by itself. You're going to divide by 12 and you're going to be left with r squared equals 507 divided by 12, and that gives us 42.25 if you type it into your calculator. And then we need to work out r. To get r by itself, you just have to square root 42.25 and you get an answer of 6.5. Okay, so your answer will just be 6.5. So as you can see, If you follow what we've been doing in the last couple of lessons, you work out the area of the cross section and multiply by the depth. This will get you the volume of any prism. Okay, now the one of the 3D shapes that is not a prism is a cone. Okay, a prism is just basically where you have a 2D shape and that's being extended throughout. So you can have a triangular prism, you can have a cylinder, you can have a cuboid, you can have a cube, you can have a pentagonal prism, you can have a hexagonal prism. All those are examples of prisms. When you look at a cone is like this. Okay, at the bottom we have a 2D shape, which is a circle. That circle keeps getting narrower as you go to the top and it converges to a point. That's why it doesn't classify itself as a prism. Okay, that's why there's a different formula to working out the volume of a cone. Okay, going over this one last time over here, because we had a cylinder, we know that to work out the volume of any prism, you need to work out the area of the cross section, which is just the 2D shape, and you multiply it by the depth. Okay, and the depth is how much through the shape that we go. So as you can see, the cross section, the main 2D shape that you can see over here is a circle. This is the 2D shape, and this circle is being extended all the way throughout the shape. Okay, the depth is how much through the shape it goes. So the depth is 12, you can see there. So we need to work out the area of the cross section. The cross section is just a circle. So we need to work out the area of the circle. And the formula to work out the area of the circle is pi r squared. Okay, that's the formula to work out the area of the circle. When you work out the area of a circle, we need to know the radius. However, we don't know the radius. If you look at this question, you don't know the radius. That's what we need to work out. So we're gonna just keep it like that, pi r squared. We're not gonna do anything to it. We're just gonna keep it as pi r squared. And what we're gonna do is we're gonna multiply it by the depth, which is 12. Okay, so we're gonna multiply by the depth, which is 12. And we know from the question that the total answer, the volume of the prism, is 507 pi. It's given to you in the question. All you're going to do now is you're going to simplify this. You're going to do 12 times pi r squared, and that's going to get you 12 pi r squared, and it's equal to 507 pi. Okay, and then because you have a pi on both sides of the equation, on both sides of the equal sign, you have a pi, you can cancel the pi's out. Okay, that's why we cancel the pi's out. Okay, so you're going to be left with 12 r squared now, and that's equal to 507. You can divide by 12 on both sides to get r squared by itself. And then to get r by itself, you can square root both sides. So the square root of 42.25 is 6.5, as you can see over here. Okay, and that's the final answer. Today we're looking at cones and spheres. So if we move on now, so what we're going to look at, we're going to look at a cone. If you use a different method and it gave you the same answer, that's completely fine. As long as you got to the same answer, that will still be correct. You don't need to worry about this method. The only reason I use this method is because it will work for any sort of prism that you could be faced with, whatever shaped prism you could be faced with. Okay, so what we're going to do, so we had a question, what's the surface area of a cone and what's the volume of a cone? So you will be given that information in an exam. You will be given the formula of a cone, volume of the cone, and the surface area of a cone in your exam. Okay, so that's why cones and spheres are slightly easier than cylinders and prisms. They're slightly easier because you will be given this box in the exam. The volume of the cone is given by a third pi r squared h, where r is the radius and h is the height. And to work out the surface area of the cone, you will do pi r L, and that will get you the curved surface of the cone. So in this case, the curved surface of the cone is this part of the cone, which is rotating around. Okay, and then what you would have to do is you would have to add the area of the bottom to work out the total surface area. This formula just gets you the curved surface of the cone. Okay, only the curved surface part, so this part of the cone. Okay, it won't get you this area of the bottom of the cone, so you need to remember to add the area of the bottom of the cone back on. Yes, even for higher. Okay, this topic is a crossover topic, so it's literally, if you get these questions, it will be right at the end of a foundation paper, and it will come up maybe around question 10 on a higher paper. Okay, so it says the diagram shows a cone. It says the height of the cone is 20 centimeters. It says the base of the cone has a diameter of 16 centimeters. And if we want to go ahead and answer this question and work out the volume of the cone, we're going to have to use this formula over here, volume of the cone. That's the formula we're going to have to use. Now let's write down that formula. It's already written down for us, but I'm going to write it down. So we've got a third pi r squared h. That's the formula to work out the volume of the cone. Okay, so we have a third times pi times r squared. Now what's r? So as you can see, the total distance, the diameter across is 16 centimeters. So that means that because the diameter is 16 centimeters, the radius is just going to be that divided by 2. It's just going to be half of the diameter. So we're just going to divide the diameter by 2, and that's going to get us 8. Okay, so the radius is 8, so we're going to have 8 squared, and then we're going to multiply it by the height. Now, the height of this cone, make sure that you work out the height of the cone, the exact height of the cone. The height is the vertical height. Sometimes they can give you this length. This is not the height. Okay, the vertical length is the height. So this thing over here that is shown is the height. Okay, so all we're going to do is that we know that the height is 20, so we're going to multiply by 20, and that's it. You've got this. You're now going to you're going to type this into your calculator. We've got a third multiplied by pi multiplied by 8 squared multiplied by 20, and that gives you an answer of 1340 to 3 significant figures. So it's going to give you, it gives you 1340.412866, but it wants it to 3 significant figures. First significant figure is there, second is there, third is there. Chop it off. This one rounds down, so it's just going to be 1340 to 3 significant figures. Okay, and this is with spheres and with cones, you will be given the formulas that you have to use. The only thing that you need to be aware of is when you're working out the surface area of a cone, you use this formula, which is pi times r times L, and then you need to make sure that you remember to add the area of the bottom face, because the bottom face, which is this one, this circle at the bottom, that's not included in the surface area. You have to remember to add it back on. Okay, so we've got one for the total surface area over here. I want you guys to have a go at this one. It says work out the total surface area of this cone. Okay, that's a good question. Why did I add 0 if it's 3 significant figures? So we've got 1340, right? That we are 0.41286. When we're rounding it to 3 significant figures, it still has to be rounded to like a close number. If we just rounded it to 134, that's it. 134 is nowhere near 1340. That's why we have to add a placeholder back on, because this is the thousands, this is the hundreds, this is the tens, and this is the units. Okay, the first 3 significant figures, we've occupied the thousands, hundreds, and tens column, but we need to occupy the units column as well. That's why we add in a 0. That's why to 3 significant figures, it would be 1340. Because if you think about it, if we just had 134, then that doesn't round to 1340 to 3 that's nowhere close to 1340. That's why we have to add a placeholder, because we've missed a column out. Okay, because we've counted 1, 2, 3, and there's a units column. Because that's a 0, we added a 0. If that was a 1, we would still say 0 or anything like that. just to make sure that it's three significant figures. Three significant figures just means you can see three proper numbers. So you can see three proper numbers here. Zero doesn't count as a number. Okay, so back to this question. Again, you guys can have a go at it and type in your answer into the chat once you've had a go. And I'll go through it in about 2 to 3 minutes. Okay, I'm just going to give everyone else 1 minute and then I'm going to start going through the answers. In this formula, the L stands for the length. So well, it's showing the 12 in this case. I'm going to start going through it now. Okay. So if I start going through it, so it says we need to work out the total surface area of this cone. When we're working out the surface area, um, you need to make sure that you're using the correct formula. So I can see some of you may not have, when some of you have written in your answers, you've used the wrong formula. Make sure that you use the correct formula. It says surface area, so we're using the second formula. Okay. Now, in this case, the length is the diagonal thing that you can see, the 12 centimeters. R is the radius. We need to work out the total surface area of the cone. So we know that to work out the area of the curved surface, all you're going to do is pi times R times L. Okay, pi stays the same. You're going to multiply by the radius, which is 6.5. So it's multiplied by 6.5. And you're going to multiply by the L, which is this 12 centimeters. Okay, and if you type that into your calculator, pi times 6.5 times 12, that's going to get you an answer of 78 pi. I'm going to convert it after. That's what you get if you type it into your calculator. Now, remember what I said, to work out the total surface area, you also need to add the surface at the bottom. Okay, and the surface at the bottom is just a circle. So you need to work out the area of the circle at the bottom. Okay, so to work out the area of the circle at the bottom, you're just going to do pi times r squared. So the radius is 6.5, so you're going to do pi times 6.5 squared. And that's going to get you an answer of 169 over 4 pi. I'm going to simplify now. And now all you're going to do is you're going to add together these two values. Okay, so you're going to do 78 pi, add 169 over 4 pi. And that's going to get you an answer of 377.776566. And it does say to three significant figures. So 1, 2, 3. This number rounds up. So you're going to increase this number by 1 and you're going to stop there. So 378. Okay, so 378 centimeter squared is your answer. Okay, if you got 245.044227, the reason why you got that was because you worked out the area of the curved surface. Okay, 78 pi is equal to 245.04422698. After that, you need to work out the area of the circle. You need to work out the area of the circle at the bottom, and then you have to add together the two values. So 245 add 169 over 4 pi, and then that would get you your final answer that you have there. Okay, so if you got that answer 245, you've just to use this, you've only used this formula and you've worked out the curved surface. You also need to work out the area at the bottom, and you need to add together the two values. Okay, so moving on, we've got a sphere now. Now over here, what we'll do is, just conscious of time, I want you guys to have a go at this one. Think about it. We've not, it's a sphere, it's the same concept, you just have different volumes and surface area formulas. I want you guys to have a go at it first and let me know in the chat what you think, and then I'm going to go through the answers with you and then we'll move to a block. Yes, I can give you extra time if you want to copy it down. For block, we may play crypto another time. I've got Fishy Frenzy planned for today. We might try next week, crypto block. So if you're This one, we had to add the area of the circle at the bottom. You only add the area of the circle when it's asking for surface area. In this example, it was asking you for volume. Volume is the space inside the shape. That's why we didn't have to add the area of the circle at the bottom. It's only for surface area, because surface area is the total area of all the faces together. Okay, that's why when you're asked to work out surface area, then you have to add the surfaces separately. Okay, if anyone's having struggles in accessing the Q&A, I'm going to put a QR code on the screen, which you should be able to scan using a device to ask any questions. Okay, so I've put a QR code onto the screen. If you guys want to answer using that QR code, that's great. If you have any questions, please scan that QR code if you can't access the Q&A. So in terms of this question, we got a question. So this formula is for the surface area of the whole sphere. In this case, you only have half a sphere. And this is only for the curved surface as well. So when you're working out the surface area of the sphere, you have to work out the surface area of the whole sphere divided by 2 and then add the area of the circle which is at the top. We're going to go through it now. But this formula that is over here, that's for the whole circle itself. So it says work out the total surface area of the hemisphere. So first of all, we're given the surface area of a sphere's formula over here, and that's the area that's the surface area for the whole sphere. We only have half a sphere. Now, because we only have half a sphere, we know that the formula is 4 times pi times r squared for the full sphere. Yes, 10 is the radius. Okay, this is the surface area of the whole sphere. We know that the radius is 10 centimeters, so it's 4 times pi times 10 squared. Okay, now if you type this into your calculator, you're going to get an answer of 400 pi. Okay, and this is the surface area of the whole sphere if we had a whole sphere, but we don't have a whole sphere. We only have half of that whole sphere. We only have that full sphere cut in half. So what you're going to do is you're going to divide this by 2. Yeah, because we don't have the full sphere, we only have half of it. So we're just going to divide it by 2, and that's going to get us 200 pi. Okay, so 400 pi divided by 2, and that's going to get us 200 pi. Okay, and it says give your answer in terms of pi, so we don't want it as a decimal. Okay, so we've worked out the surface area of the curved part. Now we need to work out the surface area of this part, this circle thing at the top. And to work out the area of a circle, you do pi r squared. So area of a circle, you do pi times r squared. Now we know that the radius is 10, so it's going to be pi times 10 squared, and that's going to get you 100 pi. Okay, so that's the surface area of the top circle. We know that the area of the curved surface is 200 pi, as you can see. You're just going to add these two together. Okay, if you got a really long number, that's probably because you kept it as a decimal. Okay, you need it to be in terms of pi. Okay, so you don't want that long number. Okay, if you type this into your calculator, you will get a long number. Yeah, so if you type in 200 pi and you wrote that as a decimal, you get 628.3185307. That's a really long number. You want to keep it in terms of pi. So you're going to add them together, and that's going to get you 300 pi. And 300 pi is your final answer. Yes, we're going to move on to a blockade today. We're going to move on to it now. Okay, so hopefully that makes sense. Bottom line over here with cones and spheres, you're going to have to work out, you're going to be given the formulas. You're going to use the formula to substitute in your numbers. If it's volume, you just substitute it in. If it's surface area, you need to work out the curved surface. So both cones, you have to work out the curved surface, and then you have to add the area of the circle at the bottom. For hemispheres, you work out the curved surface by using the formula. Sometimes you have to divide it by 2 if it's halved. Like we had a half of a sphere, that's why we had to divide it by 2. And then you need to make sure that you remember to add the area of the circle that's at the top.